Hi students, welcome to Code Pathshala. So today we will be looking at the spiral matrix problem on LeetCode. Let's look at the problem statement. The problem statement says we are given a m by n matrix and we have to return all the elements of the matrix in spiral order. So the spiral order is start from 0, 0, cover all the edges and then keep going in circle. For example, if there is a bigger one like this, you have to traverse like this. So it's a simple problem of traversal. So uh, let's see if we can solve this problem by DFS. Okay. Uh, the reason why I went for DFS and not BFS is the traversal looks like it's going to the depth first. Okay. So let's try to write the code. So we need a visited array. So visited. Okay. Boolean. Let's take matrix size matrix dot length and matrix of 0 dot length size of rows and columns. Okay. Now we have to call DFS on this matrix. Okay. Starting at 0, 0, and we have to take the visited array. Okay. Finally, we also have to return the result, which is a list of integers, right? So let's uh, create that array. Instead of passing it in every recursive call, I am just declaring it as a class level variable. Okay. New array list. Okay. So once DFS is done, our result should have the required result. We'll just return that. Now let's write the DFS function. So DFS integer array matrix int row int column and boolean array visited. Visited. Okay, so this is what we have. Now, first let's check the boundary conditions. If row is less than 0 or row can go beyond matrix dot length. Row is greater than or equal to matrix dot length or call is less than 0 or less than 0 or call is greater than or equal to matrix of 0 dot length, which is the number of columns, or if it is already visited of row of call. Okay. Or if it is already visited, what do? We don't have to do anything. We simply return. Otherwise, we have to visit this particular cell, which is visited of row of call equal to true, and we also add this to the result. Result dot add matrix of row of call. Okay, we populated the matrix array. Then we have to continue the DFS traversal. DFS is matrix of row comma call plus 1 comma visited. Okay, and in the second one we'll go to row plus 1. The column will remain same. Here we'll go to call minus 1. Here we'll go to row minus 1. That will cover all the neighbors of the current cell. So we are going to we are incrementing the columns, then we are incrementing the rows, then decrementing the columns and incrementing the rows. Okay, let's run this and see. Okay, okay, there is a typo here. Okay, it passed this case. So let's look at this through a example. Okay, so we were looking at a 3 by 3 matrix. Okay, let's say we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay. Now what we were doing is we are starting at 0, comma 0, and if you look at the code here, okay, this is our traversal. Let's just copy this here. Okay, this is how we are traversing it. Okay, so we are going to all the columns. That means we are starting from 1 and we are covering all the columns. Then we don't have anything on the right. So we will go to the next step of the execution, which is this step. Okay. Now we'll go to row plus 1. So we will keep going row plus 1. Then we'll go to, then beyond this, it is again out of bounds. So we'll go to the next step, which is call minus 1. So we'll keep going left. Okay. Now, once we reach the boundary here, we'll go to row minus 1. Okay. If you go to row minus 1, okay, you'll go here. Now, once you reach here, okay, you will go to call plus 1 again. Okay. And which is the correct direction for us. It worked for this example. But let's say there is another example. Okay. Let's copy the code here. Okay, let's say we have a bigger matrix, 4 by 4 matrix. Now, the elements we have will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Now, if we traverse this matrix, initially you will cover all the columns. Then you will go all the rows. Okay. Then column minus 1. Then you will go to row minus 1, and here the first step you will do is you will look for call plus 1. Okay. Here rest of the things are visited, so you will go here and you will go here. So that is how the traversal will be. So because whenever there is a right with this algorithm, it is trying to cover the right. It first checks for the right condition. Okay. Call plus 1. At point 9, call plus 1 was available, so it will go there. Whereas in this example, at point 4, call plus 1 was available, it went there, and that is the only one available. So the solution was correct. Whereas here, there is another column and we expect it to go up. So that means if it is going up, it should continue going up. It should not take right direction. So if we make this change in the DFS algorithm, our we will have our solution. So first let's add the failing test case and see. Okay, test case. Okay, so what we are saying is we will add one more 13, 14, 15, 16. Now let's run this and see. Something is wrong in the test case. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yes. Right. Okay. Comma is missing. Okay. If we see the test case, it expects 5, 6, 7, 11, 12, whereas we are printing 9, 10, 11, 7, 6, 5. So we are printing 9, 10, 11, 7, 6, 5, whereas it expects 9, 5, 6, 7, 11, 10. Okay. So that is the correction we have to do in DFS. So the point that whenever right is available, it is going right is not correct. If it is going up, it should continue going up and then it should go right. Okay. That is the small change we will do. So we have to figure out if it is going up. Let's say we take another Boolean saying, is it going up? Okay. Initially, obviously, it is not going up, it is going right. So it is false. Okay. Now, if it is going up, if it is going up, we will continue to go up, which is matrix of going up means row minus one. Okay. Call, visited, and okay. Whereas in other cases, here call plus one, it is going right. So going up is false. Row plus one, it is going down. So going up is false. Here it is going left. So going up is false. Row minus one, it is going up. So going up is true. Okay, let's make this change and see. Let me, yeah. Now our test case passed. So the only change we did is, so when we were at 9, so it was always going right if there is an unvisited available cell. Instead, if it is going up, we said continue going up. Don't go right. Once you reach your once you reach the maximum of going up, then you go right. So what this will make is it will change our traversal from, so all these there won't be any change. Okay, only when it is going up, it will continue to go up. Then it will go right, left, and all this. Okay, which will give us a spiral as intended. Okay, let us submit this and see. Okay, so coming to time and space complexity, it will be same as DFS because we are still visiting the cell only once. We just have one more condition saying if it is going up, continue going up. That's all. All right then. Hope you enjoyed the solution. So this way of intuitively deriving it from an existing problem is the application that you all should learn. So here from DFS, we derive whatever we want. So identifying the right algorithm to use and the modification to make is the key part of problem solving. Please practice and happy coding. Thank you for joining.